Hello friends, in today's lecture we will discuss one of very important library of Python, that is Numpy. Numpy is a library that can execute complex computational problems very quickly. That means we can use this library to solve high computational mathematical problems like machine learning, algorithms, etc. In Python we have list, which is used in place of arrays. But it's slow to process list. So to overcome this problem, we use Numpy arrays because they are much more faster than list. You can say approximately 50 times faster than list. That is an amazing feature of Numpy. So we can execute programs in Python with high speed. Not only that, Numpy has so many supporting features which makes much more easier to work with Numpy arrays. So let's focus on Numpy. It is a package for data analysis and scientific computing with Python. Before moving on Numpy, let's have quick introduction of these two fields. Data analysis. Data analysis is a process of inspecting, cleansing, transforming and modeling data with the goal of discovering useful information, informing conclusions and supporting decision making. And scientific computing is the collection of tools, techniques and theories required to solve on a computer mathematical models of problems in science and engineering. Numpy modules are used in machine learning, deep learning and data science. Numpy stands for Numerical Python and is a fundamental package for scientific computing. It is often called as an alternate to another library of Python, that is matplotlib. What is matplotlib? It is a plotting library for the Python programming language and is particularly used for data visualization. Numpy is a super useful Python library and is used for working with arrays. You all know what are arrays? Arrays is collection of elements of same type. So Numpy, it is a library consisting of multi-dimensional array objects and a collection of routines for processing of array. Now let's look into the history of Numpy. Numeric, the ancestor of Numpy, was developed by Jim Hickman. Another package, NumArray, was also developed, having some additional functionalities. In 2005, Travis Oliphant created NumPy package by incorporating the features of NumArray into numeric package. And there are many other contributors to this open source project. This library is basically written in C and Python. It has grown into one of the most popular Python libraries, and various other libraries like Pandas, Matplotlib and scikit-learn are built on the top of this amazing library. Now let's focus on its feature. ND array. In NumPy, ND array, it is the star of the show. This feature is wonderful. Here ND stands for n-dimensional array, means D stands for dimensional. Before talking about NumPy's this feature, let's first get clear about what is ND array. An ND array is a multi-dimensional container of items of the same type and size, so you can say usually fixed size. This array simply stores a sequence of numbers. Like a Python list, you can access individual entries in this array by indexing into the array, and you can access a subsequence of the array by slicing it. Indexing is used to obtain individual elements and slicing is used to obtain a sequence of elements. I think you all know this concept. In terms of numerical computing feature, it has functions for working in domain of Fourier transforms and routines for shape manipulation. It also helps in operations related to linear algebra. NumPy has inbuilt functions for mathematical operations and random number generation. So NumPy offers comprehensive mathematical functions, random number generators, linear algebra routines, Fourier transform and many more tools for numerical computing. Next feature is interoperable. The ability of computer systems or the softwares to exchange and make use of information is known as interoperability. And NumPy supports a wide range of hardware and computing platforms and plays well with distributed GPU and sparse array libraries. What is sparse matrix? In numerical analysis and scientific computing, a sparse matrix or a sparse array is a matrix in which most of the elements are 0. Next feature is performant. The core of NumPy is well optimized C code, that's why it is fast. But Python is slower as compared to Fortran and other languages to perform looping. To overcome this, we use NumPy that converts monotonous code into the compiled form. So you can enjoy the flexibility of Python with the speed of compiled code. Next feature is easy to use. NumPy's high-level syntax makes it accessible and productive for programmers from any background or any experience level. It is an open source project and you can use it freely. It is distributed under a liberal BSD license. NumPy is developed and maintained publicly on GitHub by a vibrant, responsive and diverse community. So let's conclude NumPy. NumPy is a library for the Python programming language, adding support for large multidimensional arrays and matrices, along with a large collection of high-level mathematical functions to operate on these arrays. Here is the table showing some important points regarding to the development of NumPy library. So that's all we have with the introductory part of the NumPy. Hope you enjoyed the session. Thanks a lot.